Physics Part 86. When you push a trolley in a supermarket or pull a case behind you at an airport, you are exerting a force. When you hammer in a nail, a force is being exerted. When you drop a book, it falls to the floor. The book is falling because of the force of gravity. When you lean against a wall, When you lean against a wall or sit on a chair, you are exerting force. Forces can change the shape or dimensions of bodies. You can crush a drink's can by squeezing it and applying a force. You can stretch a rubber band by pulling it. In everyday life, we have a good understanding of what is meant by force and the situations in which forces are involved. In physics, the idea of force is used to add detail to the description of moving objects. As with all physical quantities, a method of measuring force must be established. One way of doing this is to make use of the fact that forces can change the dimensions of bodies in a reproducible way. It takes the same force to stretch a spring by the same amount provided the spring is not overstretched by applying a very large force. This principle is used in the spring balance. A scale shows how much the spring has been extended, and the scale can be calibrated in terms of force. Laboratory spring balances are often called Newton balances because the Newton is the SI unit of force. Forces are vector quantities. They have magnitude as well as direction. The forces acting on a body are often shown by means of force diagram drawn to scale, in which the forces are represented by lines of length proportional to the magnitude of the force and in the appropriate direction. Force and motion. The Greek philosopher Aristotle believed that the natural state of a body was a state of rest, and that a force was necessary to make it move and to keep it moving. In this argument, the greater the force, the greater the speed of the body. Nearly 2,000 years later, Galileo questioned this idea. He suggested that the motion at constant speed could just be as natural a state as the state of rest. He introduced an understanding of the effect of friction on motion. Imagine a heavy box being pushed along a rough floor at constant speed. This may take a considerable force. A force required can be reduced if the floor is made smooth and polished, and reduced even more if a lubricant, for example grease, is applied between the box and the floor. We can imagine a situation where when friction is reduced to a vanishingly small value, the force required to push the box at a constant speed is also vanishingly small. Galileo realized that the force of friction was a force that opposed the pushing force. When the box is moving at a constant speed, the pushing force is exactly equal to the frictional force but in the opposite direction, so that there is a net force of zero acting on the box. In a situation of vanishingly small friction, the box will continue to move with a constant speed because there is no force to slow it down.